All right, welcome. This is Math 111Z, and this is lecture for 2.7. All right, so here are the things we're going to cover. Graphing vertical and horizontal shifts. That's when you take a graph and you move it left or right or up or down. Graphing a vertical compression or stretch. That's when you multiply it by a constant and it changes the shape of the graph. It's known as a dilation in geometry. Graphing reflections, that's like graphing when they flip over the x-axis. So we're basically doing all types of different transformations of a function for this chapter. Transformations. So the first thing is when you have a vertical shift of f of x, if you shift it up, like if you add c after the function, that moves it up c. If you subtract c, then it's going to move it down the y-axis c. So if I had something like f of x equals absolute value of x, we know that that graph normally looks like this. Okay. If I add a 4 outside the absolute value, that would move it up 4, and it would look like this. If I subtracted a 2 outside the absolute value, that would move it down 2, and it would look like that. Okay. So you just take the shift. If it's outside the function, the parent function, it moves it up and down. Okay. If you put it inside, then you're going to move it to the left or to the right. I want you to notice that it moves the opposite direction of what you think it would be. So if you do minus c, it moves it to the right. If you do plus c, it moves it to the left. It's the exact opposite of what you had hoped it to be, right? It is because, like, look at if I have the absolute value of x, right? Here's my regular parent function, absolute value of x. I'm going to stay with that one because it's nice and pointy and it works. If I put a plus 2 in here, it would be right here. Right? And if you look at this plus 2, what would x have to be for me to get back to 0? What would x...
Oh, -2, but it's...
A -2 would take me back to 0. So when x is -2, you end up getting 0. So it's kind of the opposite. Like you want to see that plus 2 and you want to move to the right, but that's not how it worked. If I had x, absolute value of x minus 4, that would go to the right 4. Because 4, the number 4, would take me back to the origin. So the origin lands at a positive 4. So that is, and this is inside the function itself. It's with any type of function at all. So if I had like, if I were looking at like, say, the difference of, let's say I take the parent function x cubed. So this function normally looks like this, right? If I do x minus 2 cubed, it would look like, go over 2, and it would look like that. Going through 2. Where it used to go through 0, 0, now it would go through 0, 2. If I took x cubed plus 3, then it would go up 3 on the y because it's outside the cubed. This is inside the cubed. It'd go up 3 on the y, and then it would go like that.
Is it...
So any function at all, it works like this.
Okay. And that's only with absolute?
Right. If you take and multiply a function, and you're multiplying by a number bigger than 1, then that's going to stretch your function out vertically. It's going to make it go vertically. If you multiply a fraction between 0 and 1, it is going to compress it, make the function smaller, go faster through the numbers. If it is a negative and you multiply it by a negative fraction, you're still going to make it small, but you're going to flip it over. You're going to flip it over the y-axis. So
if you multiply it by positive number, it becomes stretched out.
Right,
If you multiply
so,
it by a negative number, it shrinks.
no, if you multiply it by a positive number, it becomes stretched out. If you multiply it by a fraction between 0 and 1, it shrinks. If you multiply it by a negative number,
Wait,
it
so-
gets stretched out and it flips.
What happens if you multiply it by a fraction between 1 and 2, maybe?
There's not a fraction between, like, a fraction between 1 and 2, like 1.5, it gets 1.5 times larger. Any number bigger than 1, is gonna stretch it out. Any number smaller than 1's, between 0 and 1, is gonna compress it. So you can stretch it out or compress it. So think about what happens, let's just take a look at x squared, because that's the easiest one to graph, right? Here's the parent function, over 1 up 1, over 2 up 2, and will look like, over 2 up 4, excuse me, will look like that. And that's just the parent function, y equals x squared. If I multiply it by y equals 1/2 x squared, then it go over 1 up 1/2, over 2 up 2, and it would look fatter like this.
Oh, you multiply a variable
Right.
by that.
If I multiplied it by a 4, it would get a lot skinnier. It would go vertically stretched like this. A lot steeper, okay? So if I multiplied it by a negative, then it opens down. But like if I did it like by y equals -4, it would be the same shape as the blue one, but it would open down instead of up. Okay? All right.
Let's get this better.
So with this blue graph, I put a negative in front and it flipped it over the x-axis. All right, so a negative, if you have a negative in front of the function, just like I just did, then it flips it over the x-axis. All right, it flips it over the x-axis, just like I just. All right. All right, this shows a whole bunch of different scalings for the absolute value. So here's our original, the pink one, right here. Then they multiply it by a -2. That flips it over. So here it flips it over, and it made it go twice as fast, like skinnier, a vertical stretch. And then, so they multiplied it by a -2, and that flipped it over. And then they shifted it over +1. So right here is a +1 shift, which moves it to the negative +1. And at the end, they added 3 to it, so they went up 3. So this is our final one. They moved this up 3. Okay. So those are all the different things that you can do to one function. When you have a constant inside, like what's the difference between putting a 2x squared, where the 2 is outside the function, or a 2x squared? This is different than this,
Oh, shoot, yeah.
Do you
Right?
want to answer, or is this a rhetorical question?
Oh, you can answer it. Yeah.
The 2x squared wouldn't, well, if it's a negative, it changes. How does it change if it's positive?
Well, if it's like this one,
Oh, yeah, the 2
this would be
included. Yeah, the 2 is included.
4x squared. So it changes,
Oh, yeah.
you know, it makes a significant change of the scale factor.
So if x is, in that second one, if x is 2,
Yeah,
that would make it, that'd make it 4 times 2, right?
right. So it basically it scales it, but it does scale it differently than if you put the c in front. It scales it horizontally towards the y-axis at a factor of 1/c. scaled by that factor of 1 over c. But it is greatly dependent on what the function is, on how that scale works. Okay? So, okay, so if you put a negative in side, like if I say, hey, what's the absolute value? Well, it depends on if it's even or odd. Sometimes it won't matter at all. Let's say I have the absolute value of, let's do this one. Here is the absolute value of x minus 1. All right, touches down here at 1. If I put a negative in there, that would be negative x minus 1, right? You're like, okay, that's, if I take out a negative from both things, that would be negative x plus 1. And the absolute value of this negative right here inside an absolute value is just going to be x plus 1. So what's going to happen to this function, this is just algebraically all the same thing, is it's going to be the absolute value over here, which essentially, you see what I did when I put the negative in for x, I flipped it over the y-axis. So this is the same graph, it just flipped over the y-axis. All right.
And that's like your f of negative x.
Right, f of, yes, f of negative x. Now, if this is even, it has y-axis symmetry, and it's going to look exactly the same. But if it's odd or neither, then it's going to be a reflection over the y-axis.
What if you have a negative f of negative x? Do those cancel in?
No, if you have a negative f, if you were to have a negative f of negative f, this would flip over the y. And this guy flips over the x.
Okay.
So if in the example I just used, if this was my original function, absolute value of x minus 1, if that's my original function, and I graph negative f of negative x, the new graph would be over here and down there. Right? It would flip over the x and then over the y.
Okay, yeah.
Okay? All right. So those are all of that. When you are working on this and you're doing your homework and whatnot, feel free to use Desmos so that you can kind of see graphically what's going on. You won't have that access on an exam, but you will have it, like, it's a good learning tool. So feel free to use that. Yes?
It was on the PSAT.
I know, it's crazy, huh?
It's like, what?
I know that, yeah.
Literally,
They let you use it on some questions of the SAT now, too.
that's wild.
I know.
It just gives you the answer.
Well,
Maybe.
hopefully not, but hopefully at least you can see and use it as a learning tool and not a tool to just do it for you.